One of the most important relationships that we're going to use in chemistry is the relationship between mass and volume. For example, we're commonly wanting to measure a quantity of liquid, and when we measure a quantity of liquid, say in a beaker or something like this, there's two ways to do it. We can measure it by mass, putting it on a balance, but sometimes it's going to be easier to measure it by volume, based on how much volume is taking up in the container. Both are valid and both are going to correspond to each other through this relationship called density. So we say density is equal to mass over volume, or if we want to write this in shorthand, we just say D is equal to M over V. Let's look at how we'll calculate density, and then we'll look at some examples where we use density to solve problems. First off, a rectangular piece of metal measuring 3 centimeters by 2 centimeters by 1 centimeter has a mass of 12.0 grams. What is the density of this metal? Well, first, we know the mass is 12.0 grams. We need to find the volume. Well, we have the length, the width, and the height. We know it's 3 centimeters by 2 centimeters by 1 centimeter, so we'll say the volume is 3 centimeters by 2 centimeters by 1 centimeter equals 6. Now let's look at what we do with our units here. Centimeters times centimeters times centimeters. Whatever you do to the numbers, you have to do to the units. So our unit here is 6 cubic centimeters. Now a cubic centimeter is about the width of your pinky as a cube. Maybe a common board die would be an example of about a cubic centimeter. A cubic centimeter also corresponds to 1 milliliter. And this is a common relationship that is worth keeping in mind. What you'll find is that different groups, some will use cubic centimeters, some will use milliliters, but these are going to be very common units of measurement in chemistry, and it's worth knowing that those two mean the same. So we could say here that our density is equal to mass over volume is equal to 12.0 grams over 6 cubic centimeters. And so that's going to be 12.0 divided by 6. That's going to be 2. Whatever we do to the numbers, we have to do to the units. 2 grams per cubic centimeter. Or we could write that as 2 grams per milliliter. Let's look at another one. A saltwater solution has a density of 1.1 grams per milliliter. What is the mass in grams of 4.0 liters of this solution? All right, let's see what we've got. Now we know the density. Density is equal to 1.1 grams per milliliter. We know the volume. The volume is 4.0 liters, and what we're looking for is the mass. Now, one thing we're going to run into problems right away is that we have a unit mismatch. We have our density in milliliters, and we have our volume in liters. In order to correct this, we're going to need to get to the same unit. So the first thing I'm going to do is I'm going to change one of these so that they're the same. And it doesn't matter whether you do this in milliliters or whether you do this in liters. You just have to have the same units. Okay, so let's change our volume from liters to milliliters. So our volume is 4.0 liters. And let's change that over to milliliters. Well, remember there are 1,000 milliliters in 1 liter. So we multiply those together. We can cancel out the liters, and that will give us units of milliliters. So 4 liters corresponds to 4,000 milliliters. Now we're ready to go on with the problem. We know our density. We know our volume. We're wanting to solve our mass. Now you can plug the numbers in and then do the algebra. Personally, I really prefer doing algebra when I just have the letters in because it's easier. So I'm going to say, all right, based on this, I'm going to multiply both sides of the equation by V. And so I can say the volume times the density is equal to the mass. All right, well, let's plug it in then. Our volume was 4,000 milliliters. Our density was 1.1 grams per milliliter. And so when we multiply those together, that should give us the mass. Now, notice what happens with our units. The milliliters are going to cancel out. We're left with units of grams. So if we take 4,000 milliliters times 1.1 grams per milliliter, that is going to give us a final answer of 4,400 grams for our mass. So density is an easy way to convert between mass and volume, but you do need to watch your units to make sure that you get your units, that you have your units all be the same as you go through. Let's take this idea of density and see if we can apply it to a situation that you might encounter at some point in a field which is peripherally connected to chemistry. So for example, you are on the management team of a company that is considering purchasing a tanker truck. The truck you want has a volume of 30,000 liters and an empty mass, 15,800 kilograms. However, the route you wish to travel has a bridge with a weight limit of 25 tons. If you purchase the truck and fill it to capacity with a liquid having a density of 0.0 kilograms per liter, will you be too heavy to cross the bridge? 1 kilogram is equal to 2.2 pounds. Wow. This is a more complicated question than the one we just did, and so I would encourage you to pause the recording, see if you can work this out, and then we'll work it together. Okay, so how do we go at a problem like this? First off, we know that our weight limit is 25 tons. Then let's look at the mass of the truck. Now, we're going to have a total mass, which is going to be equal to the sum of the truck plus the mass of the liquid. We know that the mass of the empty truck is 15,800. So in order to find the total mass, we are going to need to find the mass of the liquid. So this is the first piece that we need. So how do we find the mass of the liquid? This is where we use the density. We know the density of the liquid. We know that the density is 0.80 kilograms per liter. We know that the volume of the truck is 30,000 liters. So again, we can use this to find the mass. So let's see if we can do it. So we know that density is equal to mass over volume. Again, we're going to do some algebra before we plug numbers in. We're trying to solve for the mass. So the mass is equal to the density times the volume. So now we can plug our numbers in. We have a density of 0.80 kilograms per liter. We have a volume of 30,000 liters. Again, just like we did before, we can cancel out the liters. And so this is going to give us 30,000 times 0.8, which will give us a value of 24,000 kilograms. That is going to be equal to the mass of the liquid. Okay, so we can say our total mass, coming back up here, if the mass of the liquid is 24,000 kilograms, the total mass of the truck full would be 24,000 plus 15,800 would be 39,800 kilograms. Now, is 39,800 kilograms greater than or less than 25 tons? Well, in order to do that, we're going to need to do one more unit conversion. Now, we can do this either direction we want. You can take tons to kilograms. I think I'm going to take kilograms to tons. So our two numbers are 39,800 kilograms and 25 tons. 39,800 kilograms was the mass of the full truck. 25 tons was the weight limit. And we said that 2.2, let me check that number, 1 kilogram was equal to 2.2 pounds. So 2.2 pounds equals 1 kilogram. For those of you that are not used to English units, there are 2,000 pounds in 1 ton. So we're going to need to make some unit conversions. What I'm going to do is I'm going to convert from kilograms to pounds, and then from pounds I'm going to convert to tons, and then we'll compare. So if we have 39,800 kilograms, we have 2.2 pounds per kilogram. That enables me to cancel my kilograms. And then we need to convert that to tons. We have 1 ton per 2,000 pounds. So again, we're able to cancel pounds. And so now we get 39,800 times 2.2 divided by 2,000. And that gives us 43.8, rounding, tons total. So in conclusion, we are too heavy. Now, a nice follow-up question would be, how much could we actually hold? What percentage of the tank could we actually hold and still come in under the weight limit? You can try to tackle that question on your own.